What's going on, guys? Welcome to EQT's global headquarters. Largest natural gas producer in the US, sitting here with our good buddy Toby Rice. You and your brothers are like the success story of oil and gas, of modern day, right? So you guys started Rice Energy 2007. You're able to grow it into the big organization that it was, 2 public companies, sell to EQT in the last couple of years, and then go through this whole proxy battle. And now you're at the helm of the largest nat gas producer in the US. Walk me through a little bit of this journey.
Yeah, it's definitely not something we planned being here. It's sort of just evolved over time. We started Rice Energy back in 2007 on the precipice that the application of the right technology and the right application is the key to producing differentiated results. We started that business, 3 brothers in an apartment in Pittsburgh, and grew that to 2 public companies, executing a $1 billion D&C program per year. Hundreds of employees in 2 public companies. End result of that was, a company that outperformed our peers during our time as a public company by 90%. I'm incredibly grateful for that. But also we're really proud of the fact that we created an organization that was voted top workplace in Pittsburgh. So we really built a great culture. So that was a really great ride. When we made the decision to sell, we really thought that that was going to be the step change in value creation for our stakeholders. In oil and gas, one of the biggest things you can do to improve your well economics is get longer laterals. The combination of EQT and Rice set the table to drill 12,000-foot laterals across the board. So it was an incredibly compelling opportunity. And as a byproduct, it created the largest natural gas producer. And certainly, anytime you could do anything, Exxon had the spot. Anytime you could do anything bigger than Exxon, it's something to step back and be proud about. But, we got back involved with EQT back in 2018, after they had some issues. Shareholders called us and asked if we can come back in and fix it. So after a pretty grueling, 8-month proxy contest, we took over the company in July of 2019. And it's been a really amazing evolutionary path since then, getting this organization to where it is today. But what we've done and where we're at today, I'm incredibly excited about the platform we have, the culture, the technology, the operating model we've built is really going to be designed for the future and create a lot of value for our stakeholders.
Obviously, the dojo here is a little bit unconventional, right? And I think that's kind of y'all's call sign, is to be unconventional in an industry where, when I came in, it was like the petroleum club, suits and ties, really kind of stuffy. And you guys have kind of changed that, and we've hoped to kind of do the same thing. How much has culture so far, maybe in Rice and EQT, played a part in y'all's success?
I think culture is everything. At the end of the day, what we're trying to do is generate great results. Yeah. It's not about suits. It's not about bureaucracy. It's about getting results. And so whatever makes you the most comfortable so you can focus on getting the results, that's a good start for us. Culture for us is really important. I think culture is one of those things that is really intangible, and companies, end up with the culture they end up with. We always took a different approach. We wanted to make intangible things tangible. Culture is one of those examples. For us, we wanted to make sure we had a culture that aligned with the success of an oil and gas company. And so we wanted a culture that was aligned with what we do, how we do it, and who's doing it. What we do, we want to build a culture that allows us to do one thing and do it really successfully. Drill the most economic wells. That happens by drilling the highest quality well bores for the lowest cost, delivering them to sales on time, on budget, and on design, and getting the highest price possible for our gas. It's that simple. So everything we do in our organization is aligned to making that work better. On how we do it, we build a lot of technology to help streamline the governance on everything that we do to get the results that we expect. But I don't care how many processes or how much technology you put into an organization, people are going to have to think on the fly. They're going to have to make hard decisions. Yeah. When people are faced with those tough decisions, we want our values to help guide those decisions. And our values are really important in the way that we think about the world. Our values at EQT is starting number 1, company value is trust. And that's doing what you say you're going to do and doing the right thing always. That's incredibly important to bring in a foundation for everything else that's going to be successful. You can't do it without having great trust. The second thing for us is teamwork. And teamwork for us isn't just picking up the phone and calling people and communicating well. Teamwork for us is transcends just the relationships we have with our employees. It actually extends to treating our other stakeholders like teammates. That means we care about the relationships we make with our investors, our landowners, our service providers, our regulators. We have 13 different classes of stakeholders, and we care about those relationships a lot. And we want to be great teammates, internal and external. to EQT. The third value we have really sort of dovetails into that caring about the relationships, and that's heart. And that really is about caring about what we do. And so that just means we care a lot about the actions that we're taking and the relationships that we're making. And I think that heart is sort of the engine that always drives us to do better, be better at trust, be better at teamwork, and then the last value we have, which is evolution. This has been one change between EQT and Rice. At Rice, we had our company value was innovation. But I think that's evolved into evolution, because evolution is not just about innovating, it's about innovating with purpose and making sure that the innovations we do are actually having an impact and driving the results. How do you instill a culture of evolution? That seems pretty intangible, but for us, we made it pretty simple. We think that evolution starts with transparency. And so everything we do is transparent. From the way that we communicate, we don't email, or we try not to. All communication happens in our digital work environment, open floor plans. And when you bring that level of transparency to an organization, great things start happening. People start talking. The drilling engineer starts talking to the completion guy. The marketing team starts talking to the operations scheduler. And people start having ideas when people are collaborating. So collaboration leads to innovation, all these ideas. And then to actually make those ideas create value for the company, we actually need to execute on them. And so we have a really good process that we focus on, and taking all the ideas, taking those light bulbs and either evaluating them quickly and smashing them on the ground and saying we're not going to do that, or we find ways to screw those light bulbs in and make them create value for the organization. And that's how we get to evolution. And it's all about innovating in alignment with your environment to be successful for the future. But it all starts with transparency. The last thing on culture for us is, who's doing it. The ultimate goal here is we want to have a happy workforce, because we believe that a happy workforce is an engaged workforce. An engaged workforce is going to create a ton of value for stakeholders. For us, we think that the keys to happiness is really four things that we want to bring to our employees. We want our employees to be more productive. We want them to be more challenged, more recognized, and having more fun at work. Productivity really starts by aligning everybody with what they should be doing to drill the most economic wells as possible, giving them the right technology, giving them the right focus. That's going to make people more productive. Challenging people is, we've certainly challenged this workforce over the past 18 months to basically say, hey, we're going to cut $700 million of annualized costs out of this business. That's a challenge in itself. So we always look for ways to challenge our employees here at EQT. When employees are challenged and they're being more productive and they're actually meeting these challenges, we want to make sure that we're focusing on recognizing employees. And a lot of people think that recognizing employees is really just giving them bonuses and giving them dollars. A lot of times, peer recognition is important. Saying good job, doing that in a public forum. There's many ways to recognize talent, not just giving somebody $1. And then the last thing is having fun at work. And I think this is a feature that we bring to the organization. I think that a lot of people sort of misconstrue. Having fun at work isn't about pinball machines and fun office furniture or cool art or a cafe. For us, what we're focusing on is winning. And that's the funnest thing. And actually, we can talk about the values and the alignment and the people that are doing it. And that's how you build a great culture. But, at the end of the day, nothing builds culture like winning. Yeah. And that's exactly what we're doing here at EQT is we're back to winning again and focusing on that.
Yeah. So we talked a little bit earlier about the genesis of Rice Energy, and you were super heavy into frac technology. You said you identified that you think you had a competitive advantage with that, and you saw the right opportunity, and that was the genesis of Rice Energy. Talk to me a little bit about some of the technology that you guys are excited about now, and what is the opportunity there?
Yeah, so for us, the digital work environment was really important. That's really the digital technologies that we use to help plan our business more effectively, ensure execution in the field. So that's what really the software applications that we have. Having a cohesive system, that technology has really accelerated our ability to plan, which is great. We pair that up with our digital oil field strategy, and really that's about electrifying the oil field. So there's two parts to that. One is modernizing the equipment we use out in the field, whether that's hybrid drilling rigs or electric frac crews. That's a big step change for our abilities, because that type of equipment comes with a lot of sensors.
If you look, there's certain places where we have to use compressed natural gas. If we don't have the infrastructure or the pressure from field gas, we'll bring in compressed natural gas from one of our sites. So we have a compressor sitting on another site of our gas. It'll compress into these units, and they'll drive it over the road and bring it here. That's our fuel source. These individual pieces go into these gas pressure systems, and they regulate the pressure down through this line so that it feeds the gas to this turbine.
Okay.
And so this turbine is what actually spins and makes the energy or the electricity on location.
Okay. This is your power source.
It is the power source. This is the loudest part of the operation. Right?
Yeah.
So if you look inside, it's actually nothing more than a jet engine, really, at the end of the day. So, you know, when we talk about turbines and stuff, that's literally a Boeing, I think it's Boeing, I'm not sure exactly who it is, but it's the same style of engine that you'll use on an airplane.
Yeah.
Yeah. And so the rest of this unit is really just to support this piece here.
Support that turbine there.
And then all this power goes down into the switch gear.
Yeah.
And all of these pieces basically take that raw energy and turn it into 480 volts that we can use.
I was gonna say, is this like an inverter?
Exactly.
Piece right here?
Exactly. It's got fuses and all that stuff in it as well, of course.
Yeah.
To make sure that we have power continuity and breakers and things like that.
Yeah.
But like you say, it's like an inverter. A massive inverter.
Got
So if you look behind you, that's really where the power is converted to usable energy from the raw source over to usable power for our equipment on location. Like you're saying, it's like an inverter, but it has all sorts of safeties in it as well, like breaker systems and all of that as well. But if you see these big, large lines, these are the lines that actually power the pieces of equipment which are behind us. You can see it plugging into, this is a pump unit right now that they're working on, but you can see their connectors right at the back. That's where they're drawing power into their VFDs, which control the electric motors. Okay, the variable frequency drives allow them to ramp up and ramp down.
Yeah.
Right.
The layout of location is you have your turbine over there.
Correct.
It's a power generation. It comes over here where essentially this is an inverter, and then it's converted to electricity and powers all the pumps on this side.
Correct.
That's the layout of location.
You can see here the start of what we've done in terms of changing the way that we hook up to the wellhead. So this is a manifold system that connects all of our pumps together. Conventionally, this would be 3-inch or 4-inch hammer unions. And we've changed to blocks and flange connections. You can see they're much more secure. They're torqued down to spec. A much more secure and safer connection than just a hammer union.
One of the things that I thought was interesting we were talking about on the way over here is that you guys have completely eliminated the use of hammer unions. And we saw that over there with the flanges and the way that the iron was made up. Hammer unions tend to be really just unreliable, right? You made a good comment about standard operating procedures that we put. You tie them up because you know that they have a good chance of failing. What are some of the benefits? You know, that stuff looks heavy. I'm sure that you're having to use cranes to lift it, but also it's not easy to have, you know, a team of 12 frac guys out there just hauling iron. Is the safety component the main reason that you guys have got rid of the hammer unions, or are there any other benefits to that?
I think there's two pieces of that, right? Like the primary one's definitely safety. Like you said, we have known that hammer unions have been a problem in our industry for a long period of time, right? We go so far as putting restraints on top of them because we know that they fail. My question was to find, number one, a safer connection. So a connection that's more reliable, that requires torquing down instead of just a feel for the hammer and sound and pitch. This is just a much more reliable connection and technology there.
Absolutely.
So definitely the safety component of it all. But there is a component of manpower hours, right? Like, yes, we do have to lift and we do have things, but it's a much more controlled environment where people are using wrenches and torque wrenches. There's not the swinging and there's not the tripping and fall tripping hazards. When you're carrying a large joint across location has lots of tripping hazards all over the place. And I know that lifting is a risk, but it's much less risk than carrying hundreds of joints and stepping over things, especially in conditions when it's wet or it's frozen.
Yeah. And this is wild to me that we can have a conversation right here. It's quiet, and they're fracking right now, right? They're just priming the
Priming
pumps.
up, yep.
And so when the blue lights are on, it means that they're running and you can't hear anything.
And at full bore, this will be pretty much the same sound that you'll hear.
Really?
Yeah.
The decibel doesn't go up that much when you have
That's
full
right.
operation going. It's wild.
Yeah, the largest noise generator is our sand blowing off, and then the turbine at the back there.
Yeah, so when we went over there by the turbine, it sounded like a traditional frac. You know, it's just loud,
Correct.
But once you get removed from that and you're over here on this side where the pumps are, you can't hear anything, and that's amazing. Okay, what he's gonna do now is we're gonna try to go closer to the pumps, and he's gonna tell us about what they're doing with those loops and how they got rid of treating iron. And
Yeah, so not only did we change the ground manifolds and how we connect up to the wellheads, we were the first in the nation to completely eliminate hammer unions from the pumps themselves as well. So if you look over there, you see those big loops coming out. That's again,
Yeah.
a similar type of hose technology that you'll see near the wellhead that allows us the flexibility to get rid of all the iron and then have a more secure connection from the pump over to our manifold, which then connects to our wellheads. Another advancement that we've done here at EQT, another first for us.
Can you walk me through what you have on the skid over there?
Yeah, you bet.
Obviously these look completely different than a traditional frac spread, right?
Yeah.
So in a traditional frac spread, you'd have your power in and your fluid in. Walk me through what's actually on the skid over there.
What we're looking at, Riley, is the biggest difference will be the motor and VFD. So the motor and VFD, the prime mover of the pump itself, are in those gray boxes that are sitting back on the end of the pump.
Okay.
So that's, you can think of it as your typical transmission and engine on your typical conventional pump. We've replaced the diesel pusher in the transmission with a VFD and electric motors. The output of that then goes to your traditional power end that you've typically seen. But of course, because of the torque output of those electric motors, a much more robust piece of equipment. The unique thing about Evolution is that they actually have two fluid ends or two pumps on one trailer.
Okay, so you have two of them on one.
That's correct. So that power is then split between the two pumps themselves through a coupler.
Got you.
And then, but those pieces at the end there where you see the fluid end are typical of what you'd see on a regular conventional pump. It's really drive mechanisms that have changed in this. So I think one of the really important things to note here is the advantage of that dual pump design is that we can actually have about 50% more horsepower in half the space that a conventional fleet occupies.
Really?
Yeah.
So you need a smaller pad that has a smaller footprint.
That's correct. And so when we're moving down to areas such as West Virginia that has challenging terrain, or even in an area where we want to make sure that our stakeholders are happy, we want to make sure we have the most minimal impact that we can. And this enables us to rethink our pad design so that we can have a minimal impact and be less impactful to the stakeholders that we're around every single day.
Yeah, that's actually something that you guys really have to take into account up here in the Marcellus. It's not like in West Texas where you can just build these giant pads and really don't have to take that into consideration. You guys have a lot more limitations to deal with the rugged terrain and also environmental impact as well. So I assume that's pretty important for you guys.
Absolutely. And having a flexible setup that allows us to tackle that with one package and that's sensitive to all of our stakeholders is really, really important to us.
Absolutely.
Yeah.
All right, so tell me what we're looking at here with the wellheads. I see that we got bags on them. What's going on here?
Yeah, so we operate in pretty harsh conditions up here in the Northeast, right? On top of that, we're on top of a hill as well. What we do there is that's insulation. And if you see the hoses that are wrapped around the physical pieces, those are glycol lines that keep heat on our wellheads.
Yeah.
And then the plastic wrap is to keep some of that heat insulated inside of that area as well.
Maybe some Texas operators can take some lessons from you guys after the polar vortex.
Yeah,
last
certainly.
week.
We've learned a few lessons operating up here in the freezing conditions.
For sure. And with the wellhead, you guys are actually doing some pretty cool things in terms of automation with cold bore as well. Can you tell us a little bit about that?
You know, the best place to look at that would actually be at the wellhead center. Let's go, it's that tarped area over there. Let's go over there and take a look at the control system.
Perfect.
Yeah. We're just gonna have a quick look in here.
Yeah, I see. Well, y'all are hiding back here. It's warm.
So this is your traditional setup, and this is sort of a setup we're transitioning to a different setup. So if you can look down this line, these control all the valves that we have out on location. And the traditional setup is that we use manual actuators to move things around. When we move to the Utica where we are today, we require 15K equipment. Unfortunately, the provider that we use on our Marcellus equipment doesn't have 15K stacks.
Yeah.
So what you're seeing here is more of a traditional setup that feeds into cold bore. In other areas, what we have is this traditional setup with another control system on top of it. So you can imagine if you're an operator in this area, we talked about this a little bit, but the manner in which we manage our operations, the safety critical operations, our barrier between us, the subsurface and the surface, is managed by human decisions and placards all the way up and down here. So you can imagine an emergency situation to ask a person to make sure that everything is right, close everything properly and secure this location, it's quite a task.
Yeah.
Right? So our preference is to move to an electronic system, which is deployed on all of our Marcellus operations, that have all these actuators actuated by a touch screen. No more human interaction, no more manual manipulation of the valves unless you're overriding, unless you have a failure system. It's all there as a backup, but we actuate everything through a touchscreen panel. And so that if we ever have an emergency situation, we can hit a one button and walk away from the wellhead system knowing that it's secure. without cutting in any wireline or any of those other.
Yeah, I mean, I've been a part of some pretty intense well control scenarios, and it's a lot at one time, right? And so if you're having to run in here and shut valves and get the well under control, it can be a lot, but there's no reason that the technology that we have today, you can automate all of this and feed it into cold bore, and with the touch of a button, have everything shut in and get everyone safely off the location.
That is correct. And if you go over here, you can see the cold bore. So we do have the valve positions here set up in cold bore. It can be intimidating or confusing to someone who's not familiar with the operations or we're in an emergency situation. But if you look up here, what we have are valve position actuators that show us the physical position of all the valves in our system inside of cold bore. So this gives someone an easy way to walk in here, understand which valves are open and closed, and where you need to actuate on these physical actuators over here.
Yeah, so just looking at this, you have red dots and you have green dots.
Right.
Your red dots, I'm assuming, mean closed, your green dots mean open, and so you can look at any of these wellheads and you can see, okay, this valve's open on this well and this well's shut in.
That's exactly right.
So to get to like continuous pumping, so like the goal, like the prizes we're looking for, the coach shoot for, continuous pumping, so we never shut down the pumps. Automated, autonomous fracking, so we never have to touch anything.
Yeah.
And we get incredible governance there. And the last one is pumping at warp speed, and that's pumping. How do we take advantage of all this muscle we have out here, where you frack 2 wells at once? And so that's how ultimately the biggest driver in operations and completion efficiency is going to be the number of hours you can pump in a day. And so if we can pump, our goal is to shoot to pump more than 20 hours a day. But if we do dual fracking, that'll let us pump at warp speed. We'll be able to pump 36 hours in a 24-hour period of time.
Yeah.
We'll do that by pumping multiple wells
So
at
the
once.
name of the game is the most pumping time within a 24-hour period. How can you get more?
We want to do that warp speed.
Yeah.
Yeah,
Do it safe. That's why the automation is so important.
Yeah.
Make sure that we got that level of governance so that we can go faster and still be control.
Yeah, the amount of logistics and human decision making that's involved in pumping even close to 24 hours a day is enormous, right? And it becomes, my guys have done an amazing job to get to where we are today, but it's taxing on a human being to do that every day, 24 hours a day, 7 days a week,
Right.
365 days
Right.
of the year, right? Where a computer never gets tired, right?
Yeah.
And so there comes a point where you have to supplement human decision making with automation to be able to work at an extremely high level.
The name of the game is more productivity, efficiency, while also increasing safety on location.
That's correct. We can go into the wireline van now, but I just want you to note that this wireline van is at full throttle today, right now, right? So you can look at the sound that we're able to talk just here. And if we look at that flameless heater over there or the light plant over there, it's generating more noise than this whole wireline unit is right now.
Yeah, that's crazy.
Yeah.
We're gonna take a look at this wireline unit real quick, a place that's near and dear to my heart. I was a wireline hand. They've informed me that this is the first ever all-electric wireline truck. And it's not just a hydraulic system that's powered by electricity, it is actually an electric spool. So this is pretty cool. I didn't know this existed. Let's go check it out real quick and get a look at it.
Yeah, we've been really fortunate to find a partner in horizontal that was willing to take this journey with us. When we came out here, we wanted to take advantage of the turbine power as much as we could, right? And every power on location. So this year we're looking to get rid of all the diesel on our locations, right? And this was a major step in that. It seemed like a massive hurdle, but you find the right partner who's willing to think outside of the box, think differently. Like you said, there's been electric over hydraulic systems out there.
Yeah.
But it's a compromise, right? I think there's like a very minimal amount of hydraulics on this unit at all. Is there any even?
There's no hydraulics at all on this unit. The only thing we have is a water pump out here.
Yeah.
That runs a system to be able to cool the electric motor.
Yeah, that's
and all the computer boards to go with it.
That's wild.
So you think about the environmental impact of that, right? One of the values of EQT has always been trust. And it says, do the right thing, right? I know there's going to be lots of people that argue, oh, that's not that much hydraulic fluid. We heard that as we were developing. It's like, it's not that much. But if we have the technology and the ability to eliminate that, that's just the right thing to do for all our stakeholders. So that's what we should do. And that's what we did, right?
Yeah.
We found this partner to completely eliminate that risk.
And also from an operational standpoint, when you're operating a wireline truck and you have all these different hydraulic fittings and connections, those things are always going out right now to change out hoses and things of that nature. So even from an operational perspective, if you can eliminate hydraulics, that's just easier for everyone from a maintenance and operations perspective too.
Absolutely right.
And then it's better for the environment. So it's just a win from all angles.
I think on horizontal side, I think this would be less maintenance overall to keep this unit up and running.
Yeah, I'd imagine so. You all right being on camera?
I'm on it. Can't see who I am.
I didn't even recognize him when I walked in here.
So you see here, they just got done making a run. They're breaking down the wireline guns now. Then they'll move over, stab on to the next wellhead.
They're already got a gun sucked in. They're getting ready with the lube up here. They pulled the gun into the lubricator and they're getting ready to get onto the next wellhead.
All right, so we talked about what we had with cold bore technology, and ultimately what you guys are aiming for is continuous pumping. Can you walk us through everything that you're doing here in the frac van, the heart of it all? What are we looking at here?
So cold bore is our pace-on for completions. It gives us insight into all the pieces of equipment and how they're all connected in the performance of these equipment. What started with cold bore was really just understanding the position of our valves, which is what we're showing here. But what this team has done is evolved and taken advantage of this technology to put sensors and connect all their pieces of equipment on location and connect that in. So we have things like our wireline, our other parts of the equipment that we have out here. That has really allowed us to understand the continuous operation of all the equipment, how they all fit it together. And so what that lets us do is it gives us insight into you can go to the next slide. It gives us insight into what we call the critical path. I mean, in completions, the biggest thing that's going to drive our efficiency is governed by the amount of hours that we can pump per day.
Yeah.
So let's focus on understanding how many hours we can pump in a day. And so what this critical path lets us do is see where are we fracking, where are we running wireline, and when you can see all of the wells together at once, you can see that we're always pumping at some point in time. And so you can identify the areas where you're not, see what the issues are, and then the teams can dig in and pinpoint where they need to focus their efforts to eliminate any slack in the system. And at the end of the day, this system also does some analytics that are helpful for the guys in the field. And so this is ultimately what we're looking for is pumping hours, stage progress. Really, I've seen a lot of analytics. What we try and do here at EQT is make the analytics as simple as possible.
Yeah.
Like, care about pumping hours. What are the pumping hours? Like everything else is details. It's important to understand it, but we try and make everything as simple, high level as possible. And this is a really good example. And all of this information happens by us just conducting our operations. Like, there's no extra effort. This is all really just monitoring everything that's happening out here. And that's like a seamless experience with technology.
It's kind of crazy too, because we were utilizing pace-on drilling rigs over a decade ago, right? And completions seemed to lag that. You didn't have real-time insight into the data on these jobs. So ultimately with cold bore, you guys are able to get insight from current operations and what you're doing and working towards that continuous pumping.
Yeah, it's a crazy question. It's like, how come we spend more money on completions?
Yeah.
We have a lot more sophisticated modern technology in completions. Why has completions never had a pace-on? And I think the reason is because we've always had this, the frac van screen.
Yeah.
And so we can see what's going on in location, we think, but really, what am I looking at? I'm just looking at the frac equipment.
Yeah.
I'm not looking at wireline. I'm not looking at our valves. I'm not looking at everything else that's driving the critical path and the pumps. And so I think that this has just been given us the false sense of comfort that we have an idea of what's going on. Now I think when you step back and you look at what we're doing with cold bore, you realize that this is just one small piece of the bigger puzzle.
Yeah, now you have a holistic view of everything that's happening in the operation.
That's right.
Yeah, I think it's really important to talk a little bit of where we're going with this as well. It's really important to be able to capture everything. We've sensorized everything on location. We have insight into everything that's happening, and we now have it in one central place. It's really nice to have all of that and the visualizations along with that. But now the key component is, what do we do with that data? How do we turn that into action at the wellhead? Right? And so one of the things that we're doing in the next phase of all of this is trying to really supplement human decision-making with automation where appropriate, and then, or just supplemental alerts and alarms where that's better suited for that. Right? So we're doing a lot of work in taking the data, building logic around that data that's outside of what's available today with Cold Bore, but we're working together with them to really action that data. So a good example of that is trying to automate the process of deciding when a stage has ended, when we stop pumping, and when it's safe to move to the next stage. And then building on top of that will be actually verifying all of that data and then saying, we're ready to actuate the valve. So instead of having our OSRs here on location have to go through the verification process and do all of that, we have all the data streams coming in already. So let's build a logic around that to then take that decision point out, use data to drive that decision, have all the safeguards in there, and then have that action happen automatically so that we can free up the OSRs to do checks around location, to do other things, because we ask them to do a lot of things, right? And that becomes very taxing over a 24-hour period.
Yeah.
So if we could take some of those tasks out of them or supplement their decision-making with data and make that easier for them, they have more time and bandwidth to do other things that computers can't, like walk around location, to look at key components that we maybe not be able to see on the data here, like changing out the valves on a pump. Are they doing that safely? Are we doing that efficiently? So that's the next step of where we're going once we have this data.
Yeah, if I was to look at the value proposition of what you guys are doing with electric fracs, I mean, I think there's some really obvious ones. Obviously, you're cutting diesel off the location, so you're saving on fuel costs. It's increasing your ESG initiative. You're cutting down on emissions. You know, we covered the hoses and connections and getting rid of 1502 hammer unions, things of that nature. But I think long-term vision, there's some really cool things that you guys can do in terms of really optimizing the operation. And it starts with getting an overview and some insight into data, right? And then once you have that data and you have clean data, you can actually start to optimize the operation across the frac, wireline, wellheads, everything.
Absolutely. And as we move into the next generation of completions and talk about modern optimization and efficiency, that's what we should be talking about, right? It's not just about the stages per day or the pumping hours per day, but are we getting the most out of every single piece of energy that we drive out here, whether that's manpower hours, whether that's a megawatt that we're generating on our turbine. We want to be able to optimize that to the maximum level that we possibly can through data-driven decisions, right? You know, if you take a human being and ask them to process all of those things and remember all of the history that leads up to that builds that database, it's really hard, right? But a computer can remember infinite amount of data and use all of that all at once to make a decision that has probably a little bit more background and data in it than a human being can do.
Yeah, computers are taking over the world.
And so I'm really excited that the industry is starting to move towards and start to really embrace the digital side of the business. You got to recognize that's just one part of this operating model. And I hope that people continue to evolve and not just look at the technology, but look at the culture, the people, and the process and the general strategy we're taking, because all those things are going to be helpful in unlocking the true value of shale, which is exactly what we're doing here at EQT.